Okay. Now this is test set 2 and the subject is communications, and the question that we are covering is question number 11. This question is about a vestigial sideband modulation. A band limited signal m of t, which is band limited to minus w to plus w, is passed through a product modulator. It's assumed that the product modulator is nothing but multiplying it with a cosine waveform whose frequency is omega c, and this is then passed through a band pass filter called HFF. The output of this is given to be a VSB, vestigial sideband modulated wave. Now the question also says HFF should be such that 1 HFF minus FC plus HFF plus FC is less than or equal to 1 within the bandwidth of interest. 2, it says HFF minus FC plus HFF plus FC is equal to 1 within the bandwidth of interest, and argument of HFF is constant, and 4, argument of HFF is linear. Now the 4 choices are A, all 1, 2, 3 and 4 are correct. You have to pick what are the correct choices. B, 2 and 3, C, 2 and 4, D, 1 and 3. Now we know that for a vestigial sideband modulation, the transmit filter, which is what written is here as the band pass filter, should have vestigial symmetry. Vestigial symmetry which is nothing but HFF should be symmetric about FC, should have an odd symmetry about FC. So this is FC minus FC. HFF needs to have an odd symmetry, that is, it needs to be odd symmetric around FC. Now when we down convert such a signal, this is say FC, down convert such a signal, what we are going to have is, that is, we are multiplying this by a cosine wave and down converting it. This signal is multiplied by a cosine wave or down converted. What we are going to receive is a constant signal within the bandwidth of interest, and the phase of the signal, let's assume this is a linear phase filter, is going to be linear. Now it is well known in communication theory that, let's say we have a filter HFF and then we transmit a signal, some arbitrary signal, say x of t, and we look at its output y of t. For a distortionless transmission, or for a distortionless filter, a distortionless here means we should be able to reproduce the same signal at the output of the filter without any change in the shape of the signal. It can be attenuated, that is, y of t can be alpha into x of t minus td. It can be delayed, but it can be attenuated, but you should get the signal as it is. The shape should not change. It can be attenuated or delayed. Now this is satisfied if the filter, the desired filter, let me just use another symbol for this. Let us call it H1 or H1 of f, should be a linear phase. H1 of f should have a linear phase so that you get a constant phase delay. This is linear, and H1 of f, the magnitude of this should be constant within the bandwidth of interest. Now these two conditions are satisfied by HFF if it has a vestigial symmetry, and HFF, because we are interested in recovering the signal back at the receiver from this vestigial modulated signal, this HFF should exhibit these two properties. So its magnitude, when you down convert it, that is f of f plus fc plus h of f minus fc, should be equal to 1, and argument, that is the phase of this filter HFF, should be linear. So here we have 2 and 4 as the right choices, and hence C is the correct answer. Yeah.